Lesson 108 is about radical equations. Before we get started on how to solve those, let's remember what the square root means and what its definition is. And you just have the square root. If you square that, square root of x squared, that's equal to x. And if you recall, I showed you why that is, and that's because the square root sign means to the 1/2 power. And so really what you're saying is x to the 1/2 power raised to the power of 2. And so you multiply that 2 by the half, and that just equals x to the 1, or x. So the square root of x squared equals x. And so that works for anything, whether it's the square root of 3 squared, that equals 3, or whether it's the square root of ax squared plus 2 squared, that would just equal what's inside the radical sign, ax squared plus 2. So if you square a square root and everything else underneath it, you just get the term that's within the radical sign. You simplify to that term. Understanding how a square root works will come in handy to solve an equation like this. This is called a radical equation because the square root, or the x, the variable, is underneath the square root sign. And so our first step, before we isolate the x, we've got to get rid of that square root sign. And so we can do that just like in the examples above. We can square the square root. First though, let's just get that term by itself. And so we would say square root of x minus 5 is equal to -7. Now, what we need to do is square that to get rid of the square root sign, just like we were doing above. And so we square that, but just like in all algebra operations, we can't just do something like that. We can't just square something and not square every other term as well. So we have to square the -7 also. And so then we end up with x minus 5, just what's under the square root sign, is equal to -7 times -7, or 49. Add 5 to both sides, and we'd end up with x equals 54 as an answer. Now let's check our work just to make sure we did it right. Substitute 54 back in under the square root sign, and we'd have the square root of 54 minus 5, or 49, and that would equal 7, plus 7 equals 0. Now wait a second, that does not make sense. 14 does not equal 0. This happens sometimes when we're dealing with radical equations, especially when we have to square a negative number like we did there, squaring the -7 squared. So we can't say x equals 54 as our answer. We say it's the null set or empty set, and you usually do just a 0 with a slash through it to describe that. And that's our answer. There's no solution to this. Something that should have given that away is when we first rearranged that problem, and let me just write it down here at the bottom, when we had the square root of x minus 5 equals a -7. Well, there's nothing. We can't take the square root of something and get a negative result. That's just a definition of square roots. You can't get a square root something, take the square root of something and get a negative answer. So that right there should have told us that we were going to get an empty set for an answer. Let's try another equation. This one's real similar to A. First we'll isolate the square root term because it's got the x under it. So we'll say square root of x minus 5, add a 7 to both sides, and we get equals 7. Now we're saying that square root relationship will equal a +7. Now that makes sense. That seems like that would work. So we square both sides, and we get x minus 5 equals 49. Add 5 to both sides, and we get the same answer that we did before, x equals 54. Go back and substitute that in to the original expression. Square root of 54 minus 5 would be the square root of 49, or 7, minus 7. Now that does equal 0, so that worked that time. So as you can see, it's pretty important to check your work on these problems to make sure that your answer is valid. Let's do one more. In this one, we want to get the square root sign isolated again. So we'll say the square root of x minus 5 is equal to minus x plus 5. We just move all that other stuff over to the right. Now we square both sides. And so we've got a binomial that we're squaring now. We square the whole thing. We don't square individual parts. We square that whole quantity. It's just a side that we square whenever we do this squaring. We don't just square one term then the other. It's the whole thing on one side or the other. So now we'll have x minus 5 is equal to minus x plus 5 times minus x plus 5. Okay, so we should expand that out. X minus 5 is equal to negative x times negative x is x squared. Then negative x times 5 is minus 5x. Then 5 times negative x is another minus 5x. And then a plus 25. Now let's go ahead and simplify that. X minus 5 is equal to x squared minus 10x plus 25. And let's go ahead and move everything over to the right. And we can kind of see that we have a trinomial working here. And we'll have 0 is equal to x squared minus 11x plus 30. Now let's factor that. We can factor that into two binomials. And that would be x minus 6 times x minus 5. And so we can solve for the roots or zeros of that trinomial. They're just the opposites of those numbers, 5 and 6. So that's our answer. X equals 5 and 6. Positive 5 and positive 6. Check your work, go back up there and substitute those into the original expression. If we substitute 5 in, we'd have the square root of 5 minus 5, or 0. Minus 5 plus 5 would equal 0. And then if we did a 6, we'd have the square root of 6 minus 5, which is the square root of 1. Square root of 1 is 1. Minus 5 would be a negative 4. Plus 6 is 2. 6 didn't work. 5 was the only one that worked. So we have to cross the 6 out. And 5 is the solution. So again, there, it's really important on these radical equations to check your work. So to solve the radical equations, get the radical expression by itself, square both sides, not individual terms, but the entire side, and you include everything in it. Square both sides, then simplify as you need to solve for the unknown. Check your work to make sure that those solutions are true solutions to the equations. Okay, well that's all for lesson 108.